Okay, today we're going to do 1.1, which is introducing radian measure. Now, radian measure is just an alternative unit for angle measurement. We have always used degrees, but now, just like you might use centimetres or you might use inches to measure a length, we are introducing a second way of measuring an angle. And it makes a lot of sense because 1 radian, okay, is about this big here. Okay, and there's a relationship between the radian and a radius. Basically, if you draw any circle, you cut the radius out and put it on the circumference of a circle, okay, whatever angle that makes with the centre, so here's your radius on the circumference of the circle, whatever angle that makes in the centre there is 1 radian, and the little symbol for radian is like a little C. Okay, so that is 1 radian. Now, how many radii can you fit on the circumference of a circle? Well, maybe you might have learnt that the circumference equals 2 pi r. Okay, in other words, that if you multiply 2 by pi, you get approximately 6.28 lots of the radius around the circumference of a circle. So there's actually only 6 and a little bit radians in a circle. Okay, so that actually means that 6.28 radians, or in other words 2 pi radians, is the equivalent of 360 degrees. And if we can, we try to leave the pi in the radian measure because it's more accurate, rather than writing 6.28 radians is equivalent to 360 degrees. Okay, so this pi makes it more accurate. Now, what that actually means is that 1 degree, okay, if 360 degrees is the equivalent to 2 pi, then 1 degree, I divide by 360, is the equivalent of pi divided by 180 radians. Okay. Or if we were to go the other way, I'll just find some space here. 360. 1 radian, which I've divided by 2 pi. So if I divide this side by 2 pi, I end up with 180 on pi. Okay, so 1 radian is the equivalent of 180 on pi degrees, and 1 degree is the equivalent of pi divided by 180 radians, which doesn't make a lot of sense until you actually convert those to a decimal. Right? We do like to leave it with pi in it, but sometimes it just makes more mathematical sense to actually convert it. So I'm going to get my calculator. I'm going to show you this one first of all. Okay, so 1 radian is the equivalent of 180 divided by pi degrees. So 180 divided by pi is 57.3. So what that means is that 1 radian is the equivalent of 57.3 degrees, which makes sense. If we just round that roughly to 60, okay, then you've got approximately 6 lots of 60 in a circle, haven't you? So you've got approximately 6 radians in a circle. So it's quite a big angle, 1 radian, whereas 1 degree is a very, very small angle, isn't it? If you were to draw 1 degree with a protractor, it's very, very small. So we like a radian because it is a much bigger angle and it has a relationship between the radius and radian. Okay. Now, getting down to the types of questions that we'll have. If you want to convert from degrees to radians, well, if you've got 1 degree and you want to convert it to radians, then you just multiply by pi on 180. If you want to convert from radians to degrees, So if you've got 1 radian and you want to convert that to degrees, you multiply by 180 on pi. So these are the rules that we're going to use to convert angles to different measures. So let's have a look. 120 degrees. What is that in radians? Now you should know that 1 radian is approximately 60 degrees. So you know your answer is going to be close to 2 radians. Okay, but that's just an estimation. Now for a little bit more accuracy, we are going to multiply by pi on 180. Okay, now don't forget that when you are multiplying fractions, you multiply across the top and you multiply across the bottom. All right, and that is the answer, and I could convert that to an actual angle. I could go 120 pi divided by 180, and it does. It gives me 2.09 radians. So I know I'm around about right, but this is a much more accurate answer. Okay. Now the other thing I don't like about this, 120 and 180 are not in its simplest fraction form. I can actually take that a little bit further. They've actually got 60 in common. So I can divide by 60 on the top and divide by 60 on the bottom, and that gives me 2 pi on 3 radians, and that's the best form of this angle. Now if you're not good with reducing fractions like this, use the fraction button on your calculator. On this one, it's here. So I would go 120 over 180, and I press the equals, and it breaks it down for me 2 over 3. Okay, so that's where I get my 2 over 3, and of course I can't forget my pi. All right, now example 2, you are converting from radians to degrees. So this time we're multiplying by 180 on pi. Okay. Now a couple of different ways you can do this. I'm just going to work across for a moment. If I multiply across the top, that's what I've got, and if I multiply across the bottom, what I've got. Now remember, if you've got, in its multiply, if you've got a factor on the top and bottom, they can actually reduce to 1, can't they? Okay, and then you end up with 5 lots of 180 divided by 6, which you can simplify on your calculator, which gives me 150 degrees. Okay. Now this one's a little bit different because notice how they've got 5 radians, but it doesn't have a pi in it. Sometimes that happens. We don't always follow the rules and express it with a pi. We still follow the same pattern. Multiply by 180 on pi, so I get 5 times 180 divided by pi. The thing here is when it's in degrees, we actually work it out using the pi button. We do not leave it with pi in it when it's degrees, okay? The reason for that is that when we look at an angle, if it's got a pi in it, we automatically know that it is in radians. We don't want to get confused. So we never ever leave the pi symbol, even though it's more accurate, we never ever leave it in an angle with degrees. So now I'd like you to practice these questions here, and then you can do the questions out of exercise 5B.